In our last discussion, we studied the function, the range, and the domain, as well as paired order. Now it's time to study algebraic equation. One way to work with any equation is to be able to draw a graph of that equation. When an equation has two variables, x and y, you should be able to draw a graph for that. To draw a graph, we use Cartesian coordinate or coordinate plane. A coordinate plane has two axes. The left-right direction is called x-axis, and the up-down direction is called y-axis. We put a small arrowhead at the end of each line to show that the axis actually goes on forever in both directions. The place that two lines cross is called origin. The origin is where the measurement starts. Whatever you want to measure, you start from here. Now, let's see how we can locate ordered pairs on the coordinates. We can locate any point on the coordinate plane using an ordered pairs of numbers. We call the ordered pair the coordinate of the point. The coordinates are always written in a certain order, which is x and y, separated by comma within a parenthesis. X comes first and y comes second. Let's say we have a pair number of 3 and 5. What does it mean? Let me complete my number line. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Now, 3 and 5, the pair shows that we have to move 3 units in the x direction and 5 units in the y direction. So 1, 2, and 3 is in the x direction. This is 3. 1, 2, 3, 4, 5. 5 in the direction of y. So we plot a dot. Here is our point 3 and 5. Let's say we have 4 and 3. 4 and 3. So it shows we have to move 4 units in the x direction and 3 units in the y direction. So this is our 4 and this is our 1, 2, 3, 3. We plot the dot here and we'll have 4 and 3. We have to be very careful of the order. So x comes first and y comes second. Let's say we have 6 and 7. So it says that we have to move 6 units in the direction of x and 7 units in the direction of y. So this is 4, 5, 6. This is our 6. And 1, 2, 3, 4, 5, 6, 7. This is our 7. So we move in that direction. Here is our 6 and 7. Let's say we have 1 and 2. Then we have x is 1 and y is 2. We locate them and here is 1 and 2 point. So this is how we locate our points on the coordinate. What about negative values of x and y? When the numbers are negative, the direction would change. Negative start at the 0 and move to the opposite direction. So as for the x, since we move toward right, is positive. If we move toward left, is negative. Same as for y. Negative y goes downward, which I'm going to demonstrate it with red. So if y goes downward, this is negative. If it goes up, it's positive. So let's say this is our coordinate again, and if this is our coordinate, let's say we have numbers like -4 and 6. So -4 means our x is negative, so we move toward the left. 1, 2, 3, 4. This is -4. But 6 is positive, so the y axis is positive, so we need to go up. So 6 is positive. 1, 2, 3, 4, 5, 6. Now we can locate our 6, and it's -4 and 6. So let's say we have 4 and -4. Again, 4 is positive, so we move toward right. 1, 2, 3, 4. -4 is negative, so we need to move down on the y-axis. 1, 2, 3, and 4. So here is our point. We plot the point, which is 4 minus 4. Let's say we have -3 and -2. -3 is x, so we move toward left. 1, 2, 3. This is -3. And we have -2, so we move toward down. 1 and 2. This is 2 on the y-axis. So our point is -3 and -2. Let's say we have, let me get my red. Let's say we have -5 and +5. We don't need to put the sign. So we move toward the left side. So we move to the left side of the x-axis. 1, 2, 3, 4, 5 is -5, and 5 is positive on y-axis, so we move upward. 1, 2, 3, 4, and 5. So we plot our point, which is here, and it's -5 and 5. So on a coordinate, we have x-axis and y-axis with this small arrowhead to show the direction. As x increases, the point moves further right. When x decreases, the point moves further left. Same as with y. As y increases, the point moves further up. When y decreases, the point moves further down. When we include negative values, the x and y axis divide this space up into 4 parts. Each part is called a quadrant. This is first quadrant. This is second quadrant. This is third quadrant. And this is fourth quadrant. They are numbered in a counterclockwise, and in first quadrant both x and y are positive, so we have positive in both sides. On second quadrant, x is negative and y is positive. On the third quadrant, x and y both are negative. And the fourth one, x is positive but y is negative. So let's show it with numbers. Let's say we have 3 and 4. That means we move 1, 2, 3 to the right for x, and we move 4 units, 1, 2, 3, 4 upward. So we have our 3 and 4 at this point. Let's say we have -3 and +4. That means -3 has to go toward left. So 1, 2, 3, this is -3. And then we have 4, which is our y, and it's positive. So we move toward up, and we can plot our dot. So it's -3 and 4. Let's say we have -3 and -4. -3 is here, and we have -4, 1, 2, 3, 4. We plot the dot, and we have -3, -4. Let's say we have +3 and -4. To draw 3 minus 4, it's easy. We have already our 3, which is on positive side of x-axis, and -4 on the bottom side of the y-axis. We connect them, and we'll have our dot here as 3 minus 4. Now we are at the end of our session on a coordinate plane and how to find x and y on a coordinate. Our next would be how to find its slope.